Hello everyone and welcome to PA Academy. So in this video we are going to be looking at the concept of complex number. So we are going to be looking at it from a different perspective. Alright, so this is in area to engineering maths. Alright, so without wasting time, before we get started, if you are new to the channel or you are yet to subscribe to PA Academy, kindly go ahead right now, click on that subscribe button just below the video. So if you see the option of subscribe, just go ahead and click on it right now to subscribe to the channel. Alright, so thank you very much if you have just done that. If you have not, please just go ahead right now, click on that subscribe button. Okay, so thank you very much for subscribing to the channel. All right, so now let's get started with complex number. So generally, if you are to write a complex number, so let's look at this more like a general representation of a complex number before we look at the different types of complex number that we can have. Okay, so you can have, if you have a complex number, okay, equals to, we only have the real and the imaginary parts. Okay, all right, so this right here is the real part, okay, and why this is the part where we refer to as the imaginary part. All right, so we can have a complex number in different form. Okay, so number one, we can have it in Cartesian. So in Cartesian now, if your complex number is taken to be z itself, so in the representation in Cartesian, it will be, that will be x plus the imaginary and y. So don't forget, this part is the real part, and the one that is having the j or I is the imaginary. That's this j right here. Okay, so some might represent it with j, some might represent it with a kind of I. Okay, so that's the imaginary part. Then we can also have it in trigonometry. So in trigonometry, so we are going to be having a complex number which is z as r, which is cos theta plus j sin theta. All right, so this is a representation of complex number in trigonometric form. And then the third one that we can have is we can have it in polar form, which is one of the common one. All right, in polar form, we have our complex number as r at an angle. So whatever the angle is, you're going to write it there. Okay, so the polar one seems to be common, and the Cartesian. So another one that you can have it is the exponential. So in exponential, okay, so you can have your complex number written as your r exponential j and theta. All right, so now then we can now state what some of those things represent, where our r, so you can see, if you look here now, you see that we are having quite a number of r here, this r here. So if you are wondering how do you get the value for this r, okay, so there is a way you can use to get it. Okay, so where for you to get the value of r is square root of x squared plus y squared. All right, and then for the angle, it's going to be the tan inverse. So that's going to be the tan inverse of y. So let me write that properly. Over x. All right, so once you divide y divided by x, whatever you get, look for the tan inverse of that answer. You're going to be getting the angle. All right, so basically with this now, that means if you have a complex number in your Cartesian form, which is this form, you can also use all of these plus this to convert it to either the trigonometry, the polar, or the exponential form. All right, so you might need to take note of it. Now let's look at one example. Okay, another thing I also want to mention is if you are dealing with complex number like this, okay, maybe when we get to some other but if you are watching this video as if in this series, okay, so sometimes you might have this representation of z, okay, and you are dealing with, maybe when you are dealing with I think we are still going to get there, where we start to look at the function of complex variables, or we look at analytic function. Okay, so once you see this there, like, just know that is a representation of this right here, okay, of x plus jy, okay, which is the real and the imaginary part of it. Okay, because some question will not write it out like that. Okay, so just take note. Okay, so now let's look at one example with some of these things that I've shared with you. Okay, so now let's look at this example. So in this example, it says simplify 2 plus j5 squared plus 5 into bracket 7 plus j2 over 3 minus j4 minus j into bracket 4 minus j6. Okay, now the interesting part is, leave your answer in a plus jb. Now in this a plus jb, that means we should leave it in Cartesian form. So if you go back to this, you can see A plus JB, still the same thing. Instead of using X and Y, they decide to use A and B. All right, so this time they say we should leave our answer in A plus JB. Okay, so you can see this, our A is our X, and then our Y is our B. Okay, so they just change the alphabet. Okay, so that means we have to leave our answer in Cartesian form. All right, then hence convert your answer to polar and exponential. All right, so you can see that once we get our Cartesian, like I said earlier, whatever we get as our Cartesian, we're going to convert it to the exponential and then polar form. All right, so you might want to pause the video and attempt it and see what your answer is going to be. Okay, and if you do that, let me know what your answer is in the comment section if you're able to arrive at the same answer. All right, so now let's start with breaking down what we have here. Okay, so if you look at it, we have this part that we are asked to simplify. So let's go ahead and simplify it. Now for us to simplify this, we are going to take it one after the other. All right, so we are going to take the first part, which is this. So we are having 2, so solution. So we are having 2 plus j5 all square. So with this now, we can go ahead and expand this. So that means we're having 2 plus j5 and then 2 plus j5. Okay, now let's go ahead and expand this. If you decide to expand that, you're using 2 to multiply everything here, and then we're going to use j5 to multiply everything here. All right, so let's go ahead and do that. Now if you decide to use 2, you're going to be having 4 plus j10. Then if you use this j5 to multiply everything here, we are going to be having plus j10, then plus j square 25. Okay, and then if you simplify further, we are going to be having 4 plus j20. Now this j square, when you are dealing with complex number, okay, now the imaginary part, if you have, take note of what I want to write here. If you have j raised to power 1, it's also equals to j. If you have j square is equals to minus 1, then j raised to power 3 is equals to, that's j square times j. That's going to be minus 1 times j, minus 1 times j, and that will also give you minus j. So if you have j raised to power 4, so it's also going to give you 1, because it's just like minus 1 times minus 1. All right, so you need to take note of what I have by the side right here. Okay, when you are dealing with complex number. So with that being said, here we are having this j square, and j square is minus 1. Okay, so that makes this everything here becomes minus 25. Okay, so that will be minus 25. Okay, and now we have minus 25, and then we have minus 25 here, we have 4 here. So with that, we are going to be having minus 21 plus j20. Okay, so we've been able to simplify the first part of the equation, so just take note of that. So let me just circle this in another color. Okay, so we have this part now. Okay, now let's look at the other part of the, which is this. Now let's go ahead and simplify this, where we are having let me just copy that. So where we are having this 5 into brackets. Okay, so copy, and then like that, let me just come and paste it down. So let's go ahead and simplify this. Now we are going to be using the concept of rationalization of denominator to do this. So in doing that, we are just going to be having, so the denominator we are going to look for, we are going to be having it as 3 plus j4. Okay, so let me just do it straight up. So instead of this equals to, let me just have the multiplication sign. So we are going to multiply it by 3 plus j4 over 3 plus j4. Okay, so remember, if you do this, this can cancel, it becomes 1. All right, but we want to simplify it, that's why we are doing it like this. Okay, so if you should do this now, that means you are going to be multiplying the numerator and the denominator. Okay, so if you do yours correctly, you are going to be having 105 plus j140 plus 30j plus 40j square. Okay, divided by, so if you do for that of the denominator, this 3 multiplied by 3, that's 9. Remember, this is difference, or the difference there is a sign. This is minus, this is minus here, this is plus here. Okay, so this is going to be 9, then minus, so j4 multiplied by this j4, you're going to be having minus j square 16. Okay, now let's go ahead and simplify what we are having there. So if you are to simplify the numerator now, we are having 105, then we have plus J140 and then J30, so we can add them up. Okay, so that will give us J1, okay, let me add, that will be plus J170. All right, and then we also have this 40J squared. Remember, our J squared is minus 1. All right, so that will make us to have minus 40 right here. Okay, divided by, now if you look at the denominator here, we are having 9 here, so that is just going to be 9. Now we're also having J squared over here. You can see this J squared here, and that's also going to give us minus 1. Okay, so we're having minus 1 multiplied by 16, that's minus, that will give us minus 16. And remember, plus this negative here, so that will be minus times minus, that will be plus. So we're going to be having plus 16 over here. So I hope everything is clear to this point. So for this now, we're having 105 minus 140. Okay, so 105 minus 140, so that will definitely give us 65. So we are having 65 plus J170 plus J170 divided by 25. All right, so I just want us to get rid of the denominator, so we can just go ahead and divide 65 divided by 25. So if you do that with your calculator, you are going to be getting 2.6. So you are going to be having 2.6 then plus okay, so we are going to be having 2.6 plus, so for this other part, if you divide 170 divided by 25, and that's going to give us 6.8. So that's going to be plus 6.8J. All right, so in doing this, we've already gotten the other part, which is this. Okay, after simplifying, so now let's look at let's go back to the question again, so that we are left with this part here. Okay, so let's go ahead and simplify this other last part of it. So if you are finding value in the video, guys, please give the video a thumbs up. So for that last part, we are going to be having as J into brackets 4 minus J6. Okay, and for this now, we can have it as 4J minus J squared 6. Okay, now remember, we are having J squared here. This J squared is, like I said, that's minus 1. All right, so by that, we're going to be having 4J. Remember, this minus 1 and plus this minus, that becomes plus. Okay, so we are going to be having 4J plus 6. Okay, so we've been able to sort out the other one. Now let's bring everything together. Now from the first one that we did, this was what we got, minus 21. So where we got this. Okay, so let's write minus 21 plus J20. So with this now, we are going to be having minus 21 plus J20. Then for the second part, when we did the second one, we had 2.6. This is it here. 2.6 plus, this is it right here, plus 6.8J. So plus 2.6 plus J 6.8. Now for the last part, we got 4J plus 6. Now remember that if you look at the question, there's a negative sign, which we didn't carry along. This negative, we didn't carry it along when simplifying this, so we have to include it now. So that will be minus what we had here into bracket 4J plus 6. Okay, so if you should do this now, we are going to be having minus 21 plus J20 plus 2.6 plus J6.8 minus 4J minus 6. Okay, so now let's collect like terms. Okay, let's separate the real part from the imaginary part. All right, so if you are to bring the real parts together, we are going to be having minus 21. Okay, so we've used this. Then another real part is 2.6. Okay, so plus 2.6. Is there any other real part again? Okay, and this, then minus 6. Then the imaginary part we are having, so plus, this is another one here, which is 20 plus J20. Another imaginary part is 6.8, that's plus j 6.8, and another imaginary part is this minus 4. Minus 4. Okay, let me just say that's j4. Okay, so if you should bring all of them together like this, okay, so the real part and the imaginary part, so we are going to be having, so minus 21 plus 2.6 minus 6, that's going to give us minus 24.4. So you can do that in your calculator. And if you should put this imaginary part together, okay, so that's going to give us plus j22.8. And with this now, we've been able to get the answer, okay, because they said we should leave our answer. Remember in the question, we were told that we should leave our answer in A plus j b. And if you look at it right here, so this is what we are having. So this is our final answer based on the question. Now the next thing we are asked is that we should convert our answer to polar and exponential form. Now if you look at this now, this that we are having is already in Cartesian. Okay, we already have this in Cartesian. So what we are going to do is to convert it to polar and exponential. Now let me go back to the equation I showed you at the beginning of this video in the conversion part. So you can see in polar form, this is what we are going to have, and then in exponential, this is what it's going to look like. Okay, so what we need to get now is the value for our r and our angle. Okay, so for us to do that, so let's come back to where we have our final answer. Now remember that our r, to get our r is square root of x squared plus y squared, right? So in this case, it's going to be square root of a squared plus b squared. And in doing that, that's going to be square root of minus 24.4, so that would be minus 24.4 all square plus square root of 22.8 square. All right, so if you should do this correctly, you are going to get our r. Okay, so let me write it. Our r, we are going to be getting to be 33.39. Okay, now next one to get is the angle, so which is our theta. So our theta here is going to be tan inverse. Remember, it is tan inverse of y over x, which is same as tan inverse, since we are working with a and b, so that's going to be tan inverse of b over a, right? So in doing this, we are going to be having our tan inverse of our b is 22.8 divided by minus 24.4. Don't forget the negative. Okay, now if you do this correctly, you are going to be getting your theta to be minus 43.06. Okay, so now that we've gotten all of this value, we can go ahead and get the value of our answer in polar form. So we can go ahead and say that, so therefore in polar, okay, so our answer, which is our z, is going to be, so let's go back, and we said in polar form our z is r at an angle of theta. So now we've gotten our r to be 33.39, so that's going to be 33.39, then at an angle of minus 43.06, okay, which is our answer in polar. So in exponential form, we have it to be, in exponential form, our z is what? R exponential j theta. Okay, so that means in exponential form, we are going to be getting, so we've gotten our r again is at 3.39, so that will be 33.39, then exponential j minus 43.06. okay, and this right here is our answer. So right here is the solution to this question under complex number. So we are still going to look at more examples. If you find value in this, please give the video a thumbs up, and if you have any question or any doubts with what we've just looked at in the course of this video, let me know in the comment section, and let me also know if you attempted the question before the solution. Let me also know if you arrived at the same answer or different answer. Okay, so guys, that it is for this video. My name is Prosper, and I'll see you all in the next part. We are still going to look at more examples under complex number. Thank you very much, and bye for now.